Okay, so now let's build on what we covered previously to figure out how to do the memory address decoding, given that we know the address range for different types of memory. So I'm going to use the same example that we did in the previous video and use this information to kind of help me out navigate my address decoding. We said the first range was for the ROM, and then the next one was for the RAM. And I want to figure out which bits do I care about in order for me to select between the RAM and the ROM in this memory system. Well, logically speaking, if we said this is the range for the ROM, that means any combination in this range should give me an address that actually is valid for the ROM, and then any combination of these bits should give me an address that is valid for the RAM. Now, so you wonder, like, what are the bits that are going to exclude that range between these two chips? So for example, if you take a look at these lowest 6 bits, they can have any combination that will continue to be within my 0 to 64 or 0 to 63 locations, right? And then these 6 bits are going to give me any combination of these 6 bits are going to give me a valid address in the RAM. The next bit right here actually is always 0 for the ROM, and it's always 1 for the RAM. So, that might give me an indication, or this is actually the bit I'm going to use to select between the ROM and the RAM. And the remaining bits are always, in this case, they're always 0, right? So in this case, for example, we have a system that has 16 address bits, and then only the lowest 7 bits are being used to access locations in the memory, whereas out of these 7 bits, 6 of them are going to give me a location in the memory type, and then the 7th bit is going to select whether that location is coming from the ROM or from the RAM. So if I hypothetically had that system drawn like this, so let's just say without having to go inside this RAM and ROM subsystem, like we're not going to show the chips inside these systems. Another way to look at this is if the ROM and the RAM are made out of one chip that is 64 byte, then I would say my chip enable signal is going to have what? We said this bit right here, this is A6, right? This is A0, A1, 2, 3, 4, 5, 6. So this is A6. So when A6 is 0, this is going to go to the chip enable of the ROM, and if it's 1, it's going to go to the RAM, and then the remaining bits are going to the address input of the RAM and the ROM. So these will be my my A5 down to 0. Okay, we can clean it up just a little bit. Okay. So this will be my A6 through an inverter. We'll go here. Then if it's 1, it goes there. And we said that sometimes those chip enables are actually active low. So I need to integrate that. You can put a bubble, bubble. Then also put an inverter here, and put another like double inverters here, which is really like this. And then on the top of that, if I'm using full address decoding, that means I have to worry about the remaining bits. So what happens to you have A7 all the way to A15. So A7, I need more space. So maybe I can start. Actually, let me start from here. A15, A14, 13, 12, 11, 10, 9, 8, and A7. It fits. These all have to be 0, right? And then those will be ANDed. So in that case, the let me fix it like that. So that value has to be, one more time. ANDed. And then you can put an inverter or you can use an AND here. This way. Ah, all right. I'm just gonna fill it in like this. Pretend that this is just, here we go. Okay. Like that. So this will ensure that I'm accessing the ROM when all these bits are 0 and A6 is also 0. And I'm accessing the RAM when all these bits are 0 and A6 is 1. And then once that's true, once one of these chips is being selected, obviously the values of A5 to A0 are going to indicate which location within that memory type is going to produce its data on the data bus. All right, in this case, the data bus is 8 bits. And those memory systems are producing 8 bits as well. We kind of made that assumption, right? We said each location is holding 1 byte, and that's why for the 64-byte ROM and 64-byte RAM, we are using 64 locations for each. And that's it. This is how we do memory address range. And that's how we can refer to this range to actually help us out to figure out what goes into the address decoding for the different types of ROM or RAM. Theoretically speaking, you can use the same thing to calculate the ranges for different chips if you need within the same memory type. Or you can use the method that we've covered in a previous video. Thank you for watching.